Hello everyone and welcome back. In this video we'll be looking at some of the web-based attacks. In particular we'll be looking at SQL injection. Okay, so the attacks that are carried out over the web-based architecture, what we refer to web-based attacks. So anything that goes over in the application layer through the web will fall into this category. So this not just include browsers, but also including like any client and server connections, peer-to-peer networks, and so forth. In those scenarios, typically you have like a client and server architecture. So you'll be interacting with a server, and servers can be attacked or become malicious in many ways. So SQL injection is one of the most utilized attack in this case, but also includes malvertising, URL redirection, cross-site scripting, and so forth. Okay, but in this video we're looking at SQL injections, or simply put SQLi. As you might know, SQL is a database, the way of handling database items, and there are many different SQL applications like MySQL, Oracle, NoSQL, etc. Okay, and because it's a database application, it can contain sensitive information that shouldn't be leaked. So people like to attack those sensitive information, hence SQL injection. Okay, but there are many other types of injections as well. So like XPath injection. Buffer overflow, you can think it as an injection, because essentially what you're doing is you are writing a payload and you are injecting that payload for the vulnerable program to run. Okay, there's an LDAP injection, OS commanding, and so forth. So any types of attack that you can craft some malicious code or chunks of data and you inject into vulnerable programs or servers or applications, then it will be part of the injection attack. So first, let's understand a bit more about how SQL databases work. Okay, so a database is just a domain-specific collection of data. So it's just going to have a bunch of entries about details of whatever you're collecting. Okay. A relational database is the primary current model used in database systems. Basically, well, it does a bunch of these. Okay, so you can read that. So here's an example of relational database. Basically, we have some sort of a connection of fields, and those can be captured through different columns, and they can be related to different schema as well. Okay, so here we have some creature IDs, and they have some skill code about the achievement, but they may have some other informations about maybe like their locations, their status, etc. And we can all identify the same creature through the creature ID. Okay, so SQL is short for Structured Query Language, is the most prominent of the several query languages for relational database systems. Okay, I will not get into details about how these works. You should take the CITS, what's the number, relational database unit for you to understand better about them. Okay, basically they are powerful but monolithic, and can be difficult to generate correct queries for complex questions. So for example, we can select creature ID from achievements and so forth. So we're going to have a look at that as an example. Okay, so select creature ID from achievements. What will you get returned from this query? Yep, so what it says is, from the table achievements, what we want to get is a creature ID. Okay, and because I didn't put any filtering queries in addition to this, so we're going to get all of the creature IDs returned. So in this instance, just 1, 2, 2, 3, 5. So here you see the repeated number 2. That means this is not a unique identifier. Typically, you will want to have a unique identifier, which can be mapped to other tables. Anyway, next one item is select star from achievements where creature ID is greater than 2. Okay, so now we are adding some conditions. So this will return us this. So it's going to, when you say select star, it's going to return the content of the whole row. Okay, and since we added a condition where creature ID is greater than 2, it's going to only match rows that has creature ID that is greater than 2. So if I just said select star from achievements, it's going to return the whole content of the table. Okay, so we can do some other stuff like select count star from achievements where creature ID is greater than 2. It does something similar to before, but this time I'm just counting number of rows that match to this condition. Okay, so we'll get value 2 out of this. Okay, next one, select star from achievements where skill code is S or skill code equals F. Okay, so whenever the skill code is either of those, it's going to return us this thing. Okay, so using SQL, as you can see, quite basic, but once you have a lot of conditions you like to match, the command can get quite complicated quickly. So SQLi is basically inserting malicious SQL code through an application interface. Okay, so the commands that you saw before, they're all non-malicious SQL code, but we can change that to do something malicious. We'll have a look at a few examples. Okay. And typically there are 3 types of SQLi, in-band, inferential, and out-of-band. So in-band SQLi, it's where you have a direct interaction with the SQL database. So you can see the errors that gets returned when you try different injections, and you can modify your injection according to that. And also you can apply union-based attacks where you can create the complex queries where you can grab some other information from other schemas or tables that you're not supposed to. Okay, it gets a bit more complicated as you go through the inferential and out-of-band types. However, in this video and in our unit, we will only be looking at the in-band ones. Okay, so that's what we will talk about. Inferential attacks, they are ones that you can't really get information out of directly. So things like you will inject an attack which you can confirm whether it's true or false. So that falls into the Boolean-based blind. And also you can do some timed based one. So if your statement is true, you can set your query to say sleep for 5 seconds and then return value, or otherwise it will just behave normal, something like that. So you don't directly get to see what's going on behind because it doesn't really give you any feedback, but you can still infer about the status of the database through Boolean or time-based attacks. Okay, and out of band, you need the SQL database features to be enabled to carry this out. This one is a bit more complicated, which we won't worry about that here. Okay, so let's have a look at an example SQL injection scenario. We have a 3-tier application. We have the web interface, application, and database. Then actually the example I'll show you is the application and database only. Overall application tracks own usernames and passwords in the database. Okay, the advantage is that you can manage users in real time. For example, the users table has 2 columns, username and password, with example rows being something like I just randomly created some random samples. Okay, so we have those. Then a web interface accepts a username and password in text fields, passes these to application layers as parameters. Okay, so it's going to look like this. I will show you. Here it is, the same one as what you see. So if I type in one of the credentials, mine, what it does is when I authenticate, it's just going to say login successful. If I type in a wrong password, then it says no result for your request. So it's a simple application for authenticating a user. Okay, and basically how this can be carried out is it has a code like this in the application. Okay, so string query, after all the connections are established, it's going to have select star from user table, where username is the username inputted into the application, and password is the password that has been inputted. Okay, so here note that string values must be single quoted in SQL. So application provides this for each passed string parameter. Okay, so we need to provide those single quotes to be string, and do make sure you use the ASCII version, not the Unicode one. But when I was creating this slide, it just auto converts them, and yeah. Anyway, so in this one, because since we have two columns, or we suspect there are two columns, the username and password, it should return one row that matches exactly the username and password. Otherwise, no row if failure. Okay, so here you can also change this into select count star. Then it's going to return either 1 or 0 based on our scenarios. Okay, so our normal usage that we just saw was this. Okay, which generated this particular query. So select star from user table where username is Jin De Hong and password is Jin Password. Okay, so this one we just tested and showed you. This one. Oops, get rid of 111. Okay, exactly the same. Okay, I just minimize that. Okay, but the attacker can enter the following into the login fields now. Okay, so username, I can put in anything, and in the password, we have this specifically crafted password, A, X, quotation mark, or A equals A. Okay, it just sounds very naive, but let's see what it does. So the query will become from there, select star from user table where username equals, let's say we typed hello, and password equals letter A, or letter A equals letter A. Okay, and in the where clause, what happens is we have username equals hello. This is going to give us false, and password equals A. This will likely be false, or A equals A. Okay, and this will convert to solving the AND first. F and AND is going to give you an F for false. And then F or T is going to be deduced into true. So in this means it's going to say the where clause has been true for select star from user table. Okay, so we can expect to see all the contents in the table to be returned. So let's do that. Hello, and here A or A equals A. The or doesn't have to be capital letters. So if I do that, you can see that I get pretty much similar output. I did add some few extra stuff, but nevertheless, I can see the whole content of what this table contains. Okay, and this is very dangerous because as a normal user, you're not supposed to see everybody else's credentials, right? So what went wrong? Well, the server did not check the inputs properly. Okay. Specifically the control string inputs. There are many ways that an SQL injection can happen. For example, regular inclusion of SQL meta characters through variable interpolation, string concatenation, format functions, and variable replacements. And all those things will allow you to insert SQL meta characters. So when I say meta characters, things are like a single quotation mark, equal sign, or like the commands like or, where, etc. Okay, and in certain cases where the characters are converted into, say, ASCII or hex or Unicode, then you can also include or inject hexadecimal or Unicode encoded versions of your malicious command. Okay. So how can we prevent such attacks? Well, firstly, we can try to check contents, right? So the client code checks to ensure that certain content rules are met. Maybe we can go with a rule-based where you cannot do certain words. If it matches that, you can ignore them. Server code should check the contents as well. So once the server receives the command, it should also check it. Specifically, don't allow apostrophes to be passed. This will solve our specific problem case from before, right? But the issue here is that if you do that, there are other characters that can cause problems, like comments, like the double dash, or the semicolon, which is the command separator, percentage sign for the wildcard character, etc. Okay, so the question is, which character do you filter or do you keep? Okay, so the question is, which approach is better, blacklisting or whitelisting? Okay, we can think about that. Okay, so let's have a look at different ways to inject SQLi. Okay, so now we have a different scenario where we're just going to pass in, instead of a letter inside a single quotation mark, we're going to use numbers. Okay, and then we're going to, since in the previous one, the last single quotation mark was matched with the beginning quotation mark used for last letter A, but here we are only using numbers, so we need to get rid of the last quotation mark that is hanging inside the pre-built command. So we can use the command function to filter that out. Okay, so going back, hello, blah, blah, blah. So it's not doing, and then we can say this or 1 equals 1, and then comment out. Authenticate user. Oh. Okay, so inside the command, you have to have some other random characters. Okay, so you should check the current versions. Anyway, so here you can see that 1 equals 1 is also working, and whatever I type in after the comment, hello, how are you, this is just going to be ignored. So there is also that single quotation mark that we can't see, which gets commented out with the rest of the characters that will be put in. So here we also observe that we have the same effect as before. Okay. Another one we could do is using the semicolon to attach additional commands. So here we have the semicolon, and sometimes some SQL databases will have the MultiQuery enabled per single line. But you need to know that by default, this has been turned off for some years now. But maybe possibly somebody was testing the database with MultiQuery statements and forgot to turn it off, then this can become enabled. That means you can type in pretty much anything else inside there. However, you need to know that the display panel will likely be only linked to your first query. Okay, so that means the results that gets processed will be displayed only for the first query. So whatever you do in the second or subsequent queries may not be displayed. Okay, so it's kind of like a slightly like a blind injection in a way. Okay, so you will have to link it with the first query if you want to see the output as well. Okay, anyway, by linking multiple queries or statements, you can create some more complex queries like this. Okay, so we have our first 3 lines. That is like what we typically expect, but this probably won't do anything because they're probably not a username, hello, and password equals full. And then we have this last 2 lines saying delete from user table where username like wildcard character. That means this will pretty much delete all the content in the table. Okay. So first query does nothing, but second query will delete the data depending on the database type and the level of privilege of the user. Okay, so if the user has enough privilege, you will be able to delete some stuff as well. Okay, I'm not going to do that in this demo because I need to reset it. Next one, Open Database Connectivity Application Interface allows shell injection using the pipe character, right? The straight line. Okay, so this means in some applications where you can execute shellcode, you can inject code like this. Okay, so this one you could have tried it in the MS SQL Server extended store procedures. However, you need to find the vulnerability to do this, but this is all part of the SQL injections. Okay, so we can do different versions of the SQL injections that we saw before. We can attach multiple statements through semicolons, or you can try to execute some shellcode by using the pipe. So next item is a second order SQL injection. But basically what this do is we're creating another account that will give us some access to the database ourselves. So you don't have to use SQL injection itself, but you log in with your maliciously created account and then do stuff there. Okay. So for example, we can try to create account with user equals root, and when you do that, application escapes the special character and inserts as a root. Okay. So we can log in, and attacker resets password using an existing application. Okay. Because in our previous example, if I just say user equals root, I don't have to authenticate, right? So here we don't have the root, but let's just do it with mine, Jin Hong, and then quotation mark, spaces, and put some junk in, and then when I press authenticate, it's going to return myself. So this means I can interact and possibly log in, as a root if the root account detail was in the same database. Okay. Once we have the access, then we can potentially do some update with some other stuff. Okay. Another variant is PL/SQL cursor injection. Basically, PL/SQL is a procedural language in Oracle built on top of SQL. So this one is applicable to the Oracle SQL. And basically what this allows you to do is dynamically execute SQL commands where the cursor sits. Okay. Injection techniques can be used with these structures as well. So your crafted injections can be inserted at the point of the cursors. In our current demo version, we can't do that because that's not enabled. But you can find more examples in this link below. Okay. So next one is the blind injection. Basically, it's finding vulnerability through server responses. So we're going to have a look at web-based SQLi in the next video, and that will make more sense about this. Okay, but basically, if we have some web address and you can identify something like this, ID equals 5, then this is likely be a query going to a database. Okay. So it's sending a query of ID equals 5 and it's expecting the database to return a value that matches ID equals 5. So this could generate something like select blah 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 from this particular press release where ID equals 5. Okay. Then what would happen if we send something like ID equals 5 and 1 equals 1? You can think about it. But basically, if we get press release 5 back, so we're not expecting anything to change, but returns what it's normally do, but basically that just confirms that there is a vulnerability, okay? Because this end 1 equals 1 has been executed successfully. This means it's taking those extra commands as part of the statement, okay? So this means now we know that it has a vulnerability, so we can craft an SQL query and send more targeted attacks based on that. Okay, so let's finish up this video here. In the next one, we'll be looking at SQLi examples through the web interface. Bye.